So the introduction section should have some motivation why generally this area of research needs attention of community and of this researcher specifically, and maybe just give a list of technological or medical applications that would benefit from this research. Also, one may add that examples are recycling, upcycling of plastics, or making materials for specific industry like light emitters or conductors, and general context means mentioning that other researchers did contribute to this area in the past, and there are some interesting findings. Challenges, if the author cannot identify a challenge, then the reviewer may ask a question why this work is needed at all. So even if everything looks very clear and peaceful, one needs to formulate the thing that you are doing in a form of a challenge. So that something is still unknown, there are gaps in the knowledge, because all scientific activity ideally is done in the areas where there are gaps in the knowledge. And if right now we are serving as reviewers to each other, we can suggest to authors if this gaps in the knowledge are identified and highlighted in the introduction section. And also a very good thing that originates not from analysis of ideal paper, but more from the community of grant proposals and industry and interacting with managers. So if the declaration of challenges is followed by criterion of success, then people with mindset of the managers will take it very, very positively. So like, here is the challenge, but how do I, as a reader, know if in what follows this challenge is overcome or not? If the scientist just entertained his or himself by doing some interesting calculation without achieving something valuable for industry or other scientists. So some verbal criterion of success is great. Another thing, so by now we were working a lot more than about 2 months to formulate the remaining sections of the paper, and we were discussing that as in a detective story, the human brains will accept the writing better if there is a mystery, if there is a unknown question, and if the style of thinking would work better if, as a reader reads the paper from the beginning to the end, there is a hypothetical answer to this challenge. So in example of Mead's paper, I would say hypothesis is that by selecting appropriate conditions of light, one can decompose polymer on its original precursors that later will be available for repolymerization. So instead of just decomposing polymer on random fragments, one can literally regain original precursors, and then it can be proved right or wrong with computations. In other projects, this hypothesis can be different, but presence of this explanation of hypothesis is really valuable, and as reviewers, if you can verbalize this hypothesis or just glance through a paper and then type in 10 words what it is, it may serve as a feedback to author to understand whether his message was perceived well by the readership. And it is a common, in science it is not so common, but in all other activities, the original thoughts of author are interpreted often very differently by a reader. And it's good to check that message is passed well. Then ideally the introduction can be formulated as suggested options for proving this hypothesis right or wrong. For example, one can say, in order to study reaction mechanism, one can try simulation by this and that method that hopefully will answer, will prove this hypothesis right. And about closer to the end of the introduction section, one can focus on practical aspects, on methodology, and additional wave of credits to other contributors to this area from practical side. So if we are doing computations, we can credit those who are designing methodology or applying methodology to solve similar problem. Often we just borrow methods from literature and then one needs to give a credit to it. If one designs a method, then reviewers will be much more critical. And also, as reviewers, we may check if the author expresses healthy criticism to his own methods. So if there are words that author recognizes that the methodology is not ideal and there are ways to improve it, it makes really good impression on reviewers and editors, and as helpers to authors, we may credit author for having such statements or prompt to edit if it is missing. And at the last paragraph of the introduction, one may just provide informal table of content, just briefly mention the sections like methodology, results, discussion, conclusions, and very, very briefly, like half of a line, half of a sentence, tell the content of each section, not details. And it looks a little ridiculous and obsolete, but for some people it helps to prepare minds to absorb the rest of the paper. So I will take another 30 seconds to upload updated version of Mead's paper and share it with everyone, and then I will check if all materials are seen, and then we'll go to reviewing activity. The is ready. So let's start from Mead's. Oh, no, this one, updated version. Let's go over it. And so the abstract is basically planned for the next meeting, but Aaron has some suggestions to abstract. Let's go quickly to the introduction, and Mead, please consider Aaron's questions, and if there are some questions, it means one can make it more clear. So in motivation part, you wouldn't suggest to shorten or simplify first two paragraphs. This first two paragraphs sound really well as part of a proposal. I don't know, maybe for paper it can be condensed, but it's like easy, pleasant reading. Then for general challenges, Yvonne is asking, it is unclear what is general challenge for this research. I give some suggestions, but maybe Mid, can you briefly tell how you see general challenge yourself?
Challenge in why we're doing it, or challenge in our work in and of itself?
No, challenge for the globe, for everyone in the world. Like what is challenging in practicing this upcycling of biodegradable polymers?
Yes. So I think his question is valid, because I think of many challenges that come up. And so to clarify what we are highlighting would be a good exercise. As in first glance, the challenge is, the way I'm going to word it is to understand these process that has been shown to be possible in experiments, such as degrading a polymer and then it being used, the monomer blocks are being reused again. And so for us to be able to analyze that would be the overall goal. But that specific challenge, that's a very good question. I will get back to that.
But let me offer a suggestion. With knowledge of your results, it looks like photo excitation may break polymer onto random distribution of products which will be not reusable for repolymerization. And the challenge is to select such polymers and such light conditions which will be able for selective bond breaking to break it onto specific pieces that can be used back.
Yeah, I agree with that. My instinctive thought was that was work that has been done by the previous researchers, the experimentalists, right?
But it was done once, and through computational modeling, one can find trends and predict other materials and conditions that will follow this strategy.
Okay, so we could still be consistent with their challenge, but look at it from our tools. Okay. Okay.
Would it make sense for you? Okay, thank you. Yvonne is asking for either chemical formula or more detailed explanation of the polymer. Then next question, how the bond between FDCA and nitrobenzene is formed in the first place? Mead, can you tell briefly?
I would have to just quickly look at, I actually have the paper in front of me, how it's specifically formed. I mean, I know the location, but the
based on your training in organic chemistry, can you say some smart words like cycle addition, 4 + 4 S to N? I think you were asking about that.
I guess that terminology, I guess I admit it's a bit weak. I specifically can just, like, I oddly enough, I know like free radical polymerization and such, but when it comes to if you're asking from one atom to another in particular, I admit I don't know the terminology.
But please inspect in the original paper and copy paste some terminology.
I can do that.
Interpreting your question right? Okay, so it needs a little bit of organic chemistry flavor.
I can do that. Yep.
Okay, thank you. Understanding and control of basic processes. Yvonne is asking, is it available from experiment? Maybe.
As in, is the information available from experience? The experiment has been conducted, and so we are comparing our results with theirs, and so we are trying to use these tools that we have to once again look and try to understand this challenge that we're trying to overcome. Is information available from experiments? We have specific information, but not all, no.
Okay, so we are not quite pioneers in this for this specific compound, but again, through modeling and reconstructing correct processes, we may learn a lesson and offer to utilize this trend for other polymers. Ewan, would you take this? Okay. Aaron is asking what are parameters of the study? What are independent variables?
Well, we're choosing the type of energy in our, let's say, force fields that we're using. I mean, those are controllable. What independent variables do you control for? I don't understand. What independent variables do you control for?
I think Aaron means you already answered excitation energy, your main parameter, like wavelengths. Aaron, would this answer satisfy you?
Yeah, but I guess my main point would be it's like a lot of things in DFT that you can't directly apply them to experiment. So it's like, so I think like the main thing that you control for is like the wet or dry environment. That's like the most insight you can gain, but you can't say it's like we excite at 2 eV, so experiment should excite at 2 eV.
Oh, okay.
I guess that's kind of the point I'm getting at.
So you're suggesting to be careful with telling that we literally control wavelengths and be more qualitative.
Yeah, just the way that the paragraph came out, it sounds like it was trying to try to use computational numbers and apply that to experiment, which is, I mean, sometimes it can work, but you just kind of have to be careful.
Okay. I have a suggestion independent of this question. It is like number 3 here highlighted. So, and it partially agrees with what Aaron is told. Maybe add a secondary hypothesis, tell that one hypothesizes that presence of water facilitates correct direction or desired direction of a reaction. I mean, Mead, what do you think? Something you can polish it and add it as a secondary hypothesis?
Yeah, I think I'd have to do an edit and then just get another perspective because, I understand what you're saying. It's just how to word it properly is the question in an easily readable manner. So. Okay.
Ewan is asking again about parameters, frequency or power density. Power density, yes, but in this simulation we do not change it. We can, but we don't. Yield of what? Mead, can you comment on this?
The yield is the fragmentation.
Okay, or yield of the formation of the desired monomer that is ready for repolymerization.
Yeah, I would include that same fragmentation specifically. The one that is recovered and reused for repolymerization.
Yeah, please polish it. side, Yuan is asking what are side byproducts. Let me try other products which are not ready for repolymerization. When the polymer breaks on smaller pieces, which is interesting for us as scientists, but from industrial perspective, they are not desired. Yuan, would you buy this? Okay. So this general computation approach yet needs work, and here are some general suggestions. As you tell it, ab initio molecular dynamics, it's not clear, do you mean ground or excited state? And here, it sounds by word that you are opposing molecular dynamics and DFT. Well, they are not enemies. DFT can be part of molecular dynamics. Just try to polish this place.
Okay.
Okay. Rabi is a person with uppercase, and maybe some references would be appropriate here.
Okay.
Exceptional, I think it is. You're trying to give credit to previous works in the telling that they're good, but if authors tell brag, it will be not appreciated by reviewers. It's better to remove it or express some of the criticism, like in some cases under limitations, recognition of weaknesses of the method is appreciated by community.
Okay. Fair enough.
Last paragraph is great, and I do not think you need these subsections. Just remove this yellow stuff and it is ready to go. More verbal comments to Mead's introduction. If not, let's go to the work by Amir. So we'll look on abstracts and letters to the editor next time. Mead criticizing that this abbreviation is not defined.
Yeah, right.
Okay. I keep suggesting to use the word charge injection as frequently
I didn't revise introduction after revising result and method section. I just keep that.
Yep. But
I will address them, sure.
So I'm not criticizing, but just looking as paper is already written. If you will highlight doping, smart reviewers will see discrepancy. It is what is done and what is used as a verbal description. So if we try to be more general and make analogy between charge injection and doping, it will go through easier.
Okay, sure. Dr. Killian, in the first paragraph, that was Dr. Shah's suggestion. We mentioned the challenge or novelty of this paper, maybe considering the excited state. So I'm not sure if it works for this study or no. What's your opinion?
So treatment of excited state in this paper is very introductory. It is novel, but if one wants to focus on excited states, one may want to compute a little bit more. So it is like additional by wall to treat excited state. If we brag and highlight it as a main aspect, reviewers may not be happy. It is novel, I agree, but it is only opening door for some additional explorations.
Okay. Yeah. So for periodic boundary conditions, should we emphasize that into introduction? Is that such an important, for instance, having a periodic model or just maybe oligomer? Should we expect a very big difference in the result?
It is not dramatic change and groundbreaking things, but I don't know how to write and how to polish, but here are my vision and argument. First, your main result is match of experiment by use of k-points, right?
Yes.
And use of k-points is not possible without boundary conditions. So in some sense, your main result depends on the use of boundary conditions.
You mean periodic boundary conditions?
Periodic boundary conditions, yes. So if you would use oligomers, maybe agreement with experiment will be 4.
Very good point.
And we do not need to highlight it, but we need to agree between us that it is the case.
Okay, and what was the second one? You mentioned 2 points.
No, first that agreement depends on k points, and second that k points are not possible without periodic.
Okay.
Okay. So, yeah, you see, Yunus mentioning that.
Yeah, he's right. I will address that.
Okay, so it is not question, but it is more rhetoric question and suggestion to polish and avoid sharp edges. So Mead is asking about equivalence of charge injection and actual doping. So maybe you may try to add another paragraph or sentence about this analogy, because if everyone is asking inside the group, the reviewers will ask as well, and you may prepare this question to answer this criticism and questions ahead. But we believe that there is an analogy, but this analogy has some limitations. So
can you provide me some tips, Dr. Kinney, for that? How to add more clarification or more illustration to that?
We are discussing it all the time. Maybe you try to your version, and then in the next iteration, I'll type in something.
Okay.
Both doping and charge injection affect occupation at the occupation of frontier orbitals. So here is the analogy. And difference is that when adding doping, system remains neutral in general, but when injecting, it becomes charged. So there is a similarity and differences. Mead is asking about word band gap. I wonder if energy of band gap will resolve the issue.
Yeah, you're right.
Aaron is requesting connection between these two sentences.
Okay, I will try to make it more clear in the next version.
Probably gap is important for photovoltaics on one hand, and on another hand, doping and charge injection change the gap. Therefore, these two things are connected.
Okay, yeah, I will.
Aaron, would you buy it? Or
that's my impression. I think it's kind of mixing two different ideas, but I mean, it would just be arguing over semantics.
Okay. Gap connecting.
Sure.
Phrases, it's a grammar. Next. Okay. This comment is for 2 sentences above. DTFT can be select. Mead, can you explain your question?
Yeah, so if you look above where it says to address this, density functional theory can be utilized, and then you instantly kind of shift to it being one of the most popular computational methods. So it seems like you're trying to say you utilize it. Well, why are you utilizing it? And then you're kind of promoting it being a popular computational method. And
okay.
so,
okay, let me sure as I see your question. So you would suggest maybe inversion. So first introduce the theory and then tell that because of its benefits we try to do it.
Yes, you like promote, explain, exactly. Introduce it whatever way you want, and then explain why you're using it.
Amir, does it make sense?
Yeah, we can do that also.
Okay, good, thank you. Energy density per electron. Mead is asking for each electron or for which electron?
I'm just saying per electron mate seems a bit. A local density per electron. I don't know. I guess per, I think of like a ratio instantly. And yeah, so I would just.
So maybe it's just verbal, and if you were taking it as from references Czech language that they're using there.
Sure.
Resulted in producing. Okay, I think it is just semantics.
Yeah. Good.
So Mead is criticizing that here you refer to current conjugated polymer model, but at this point it hasn't been yet introduced.
Yeah, right.
Maybe one can tell conjugated polymer model that we are going to introduce in what follows.
Yeah, right. I will discuss that.
Yun is asking whether a list of achievements of DTFT studies are needed here.
Actually, this is maybe my writing style. Before the conclusion paragraph, I usually review the usage of the density functional theory or previous work in this field. Right. So I don't know, what's your suggestion?
Maybe revise this paragraph and check, like keep only those examples which where polymers are similar to the one you are exploring, or the conditions are similar to what you are exploring. So if any of this works use momentum distribution, or any of these works consider charge injection, then they would be very appropriate. Ewan, would you accept it? Okay. So if it is just general application of DFT of some very irrelevant polymer, then maybe it can be skipped. But if there is analogy not only in methodology but also in the system or in conditions, then keep it. Mead is checking if the sentence can be shortened, maybe chopped on two. And here I'm asking if alternative methods.
You mean other computational methods here?
Yes, yes. And we do not need to be experts in them, just from literature check what are the alternatives. Like in chemical community, people use like semi-empirical, which are cheaper and less precise frequently. And in physics community, people use like GW. Just try maybe a couple of references so that we do not look narrow-minded followers of DFT. So K-point sampling is mentioned only here, but maybe one can mention it earlier if it is really important. So Aaron is giving comment. In the excited state, there are two possibilities. Hall and electron have spin pointing in the opposite direction. Hall and electron have spin pointing in the same direction.
We had the triplet, I think, here.
Yes.
Sure. I will.
So
I
just
always have this problem with SP
Yep.
polarization. I will address in the whole manuscript. Sure.
In most of the experiments, we do not have luxury to tweak angular momentum. So this state with singlet and triplet, they exist independent of our wish and of our calculations, but sometimes conversion from singlet to triplet may happen. So system, instead of recombining into ground state, can convert into triplet and have a long-lived excitation there. Just use the right verbiage. It doesn't need to change any of the calculation. Thank you, Aaron, for suggestion. So Aaron suggests to mention TD-DFT method and be a little bit self-critical to use of DFT, telling that it is approximation, maybe single particle approximation. So one of the standard tools is TD-DFT, and we shouldn't pretend that it doesn't exist. So if maybe Aaron will share reference if you need it.
So here I get a little confused. We didn't use the time-dependent DFT. It's just ground states, right? I don't. What's the problem? You mentioned why I address some time-dependent DFT.
Let me quickly comment.
Sure.
So TD-DFT doesn't have any time dependence in calculation. It is abbreviation for a method that computes absorption spectra with higher precision than method that we use.
Okay.
Okay. Any verbal questions to Amir? If no, let's go to the work by Aaron.
Thank you all for the comments.
Thank you. I think it's very helpful mutually from each side. Mead has problems for paper starting with abbreviation. Maybe one can tell so-called compound and then brackets. Mead, would you be happy?
Yeah, just like instantly starting with a chemical name. Just yeah.
Okay. Mead is asking to explain what are defect densities.
Number of defects per volume.
Okay. What is deep trap state formation? Let me try. There is a gap, valence and conduction band, deep trap when a new state is in the middle of the band gap, and shallow trap when it is close to either conduction band or valence band. Mead, are you happy?
So just that band gap is extended.
If trap means additional state contributed inside the band gap.
Okay.
And depending on the energy, it can be categorized as deep or shallow. I'm looking for sentence for a challenge, maybe like to degrade or not to degrade, or maybe the hypothesis that PL efficiency is defect tolerant, as you mentioned at the beginning of introduction. Would it be possible to do something like that, Aaron?
You mean just for the beginning of that paragraph?
Somewhere to specifically declare here is the challenge, or here is the hypothesis.
Okay.
That we try to prove, so that it will be easy to digest for a reader. And I think then you go directly to specifics, and maybe between general description of a problem and challenge and hypothesis, one can maybe you can just copy paste from your previous paper, so quickly sketch what are typical or what are available or unavailable computational tools to address this type of challenges. And again, it will be a good option to credit potential reviewers or credit yourself for your previous works. Are there more questions to Aaron? If no, let's go to the introduction by Yvonne. Aaron suggests a phrase, potentially transformative areas. Aaron, it's really good language for winning proposals. Good. Yeah, thank you. Good suggestion. Several. Yeah. Amir and myself suggest to add references, which is natural. Mead suggests different word instead of light mass. I don't know. It's matter of taste. I'm fine either way. Proposed by whom? Probably by authors of experiment. Is it right that we want to prove the hypothesized direction path? Or if it is yes, one can write it. If no, just forget about it. Aaron suggests products. Okay. And maybe one can emphasize and tell not just general study, but extract general trend and find and apply them to another classes of materials with hope to explore availability of similar materials as superconductors. Just be a little bit reckless and brave and provoking at the beginning. I think in this case it's not bad. Molecular dynamics as opposed to transition state and scan of surfaces, right? So maybe one can again provocatively highlight here when you tell about non-Born Oppenheimer, maybe it is needed because if one jumps to different potential surfaces, reaction can go into different paths, and it's not bad to bring it to reviewers. Here it sounds like should be a reference to Sergei Tretiev. Amir is suggesting to add one more sentence, so to say, concluding the overall introduction. Okay. So many thanks to everyone. Other verbal questions to Yvonne's work? Okay. Let me express gratefulness for everyone to play this role of reviewers. So as authors, please consider to implement changes to your vision, and if you agree with them, and let's try to consolidate all sections that we worked on during the last 2 months into a single document and try to go over them next meeting.